Hi, this is Sushma, working as Associate Professor in the Department of CSU at BBC Institute of Technology and Science. Today we are going to discuss about association analysis. And the topics that we are going to cover here are: what is association analysis, that is the definition of association analysis, item set, support count, the difference between support and confidence, frequent item set generation, and the main concept that we are going to discuss here is rule generation. Coming to the definition of association analysis, it is nothing but identifying the relationships that are hidden in large data sets, and these uncovered relationships will be represented in the form of association rules. We can see it with an example of a market basket transaction here. In this market basket transaction, we are having 5 transactions where items in each transaction are recorded here. By observing these transactions, you can easily specify that wherever there is a diaper, there is a beer in association with diaper. Therefore, we can say that diapers implies beer. The association rule will be represented with the help of an arrow symbol. And coming to the definitions of item set and support count, here a set of 0 or more items, that is a collection of 0 or more items, can be termed as an item set. Okay, and here if an item set consists of k items, then you call it as a k item set. For example, here I have considered an item set consisting of 3 items: beer, diapers and milk. Therefore, it is called as a 3 item set. And another important property of an item set is support count, which is nothing but the number of times a particular item set is being repeated in all the transactions. Let us see with an example what we have considered earlier. In this market basket transaction, if the item set what we have considered earlier is a beer, diaper and milk, see how many times that beer, diaper and milk combination is repeated in all the transactions. If you observe here, it is repeated in 2 transactions, that is transaction ID 4 and 5. Therefore, the support count for this beer, diaper and milk can be considered as 2. And coming to the definitions of support and confidence, and the main strength of an association rule is mainly measured in terms of support and confidence. Support is here identifies a rule which is applicable to a given data set, while if you consider the confidence, it determines how frequently a particular item appears along with a particular item X. If I consider Y, how many times Y appears along with X, that is called as confidence. And the symbolic representation for support and confidence can be represented as follows, which is shown here. The support count of X union Y by total number of transactions N is nothing but the support value, and the support count of X union Y by the total number of times wherever X is present in all the transactions is nothing but the confidence. And here how this association rule mining algorithms are designed is mainly categorized based on how the problem is decomposed. It is mainly decomposed into 2 major subtasks. The first one is frequent item set generation and the second one is rule generation. What do you mean by frequent item set generation? Here the main objective is to identify what are all the frequent item sets that are being repeatedly found in the entire transaction, and those items that must satisfy the minimum support threshold value. And coming to the rule generation, now once the frequent item sets are identified for all the transactions, then from those frequent item sets here you need to extract all the rules which are having the high confidence value. Therefore, when you are considering the frequent item set, it is concentrated only on the support value, whereas in rule generation you mainly concentrate on the confidence values. and the rules what you are generating with the high confidence values are called as the strong rules. And coming to the rule generation, here the rule generation describes how to extract the association rules efficiently from a given frequent item set. That means when you are given a frequent item set XYZ, you need to identify what are the rules that can be generated from that particular frequent item set XYZ. Suppose if a frequent item set what you have considered is consisting of k items, then the number of rules that can be produced from that k item set is 2 power k minus 2 association rules. And this is the number that is generated by ignoring all the rules which are having the empty values either on the antecedent or on the consequent. That is the reason why you are representing here as 2 power k minus 2. Minus 2 is nothing but the item sets which are the rules which are having null value either on the antecedent value or on the consequent value. Let us consider the item set here. Item set what I have considered is 1, 2, 3 is the frequent item set, and let us see what are the association rules that are generated from this frequent item set. Here if you observe, the rules that are generated are 6, 1, 2 implies 3, 1, 3 implies 2, 2, 3 implies 1, 1 implies 2, 3, 2 implies 1, 3 and 3 implies 1, 2. Here I have not represented any rule specifying 1, 2, 3 implies null. There is no such rule. Therefore, I am neglecting all the rules having the null values either on the antecedent or on the consequent. Therefore, the number of rules here that are generated are 6, which is nothing but 2 cube minus 2. 2 cube is 8. 8 minus 2 is 6 rules are generated from this frequent item set having 3 items. Let us see how the rules can be generated using a priori algorithm. Initially, you need to identify all the high confidence rules having only one item on the consequent of the rules. Initially, that means you are identifying only the rules having one item on the consequent of the rules, and these rules are then can be used to generate the new candidate rules. Here you will be generating all the candidate rules from a particular frequent item set. After that, you will be identifying only the correct rules which are having the high confidence value. Let us consider, for example, if the initial rules, high confidence rules, what we have considered is A, C, D implies B and A, B, D implies C. Then combining these two rules, I can have a rule specifying that AD, if you observe on the antecedent side, I am having AD as common, and AD implies BC can be generated by merging the consequence of both the rules. And this rule generation, this entire rule generation can be represented in the form of a lattice structure. Initially, the initial value of this lattice structure starts with A, B, C, D implies null. That can be considered as the root value. From that, if you observe here, I am generating 4 rules. This is the first step what you have to identify. I am generating the 4 rules where I am having only one item value on the consequent side, which can be given as BCD implies A, ACD implies B, ABD implies C, ABC implies D. Okay, and then here that is the first level. Coming to the second level, here I am combining the consequent item sets, consequent rules what I have generated in the previous level to generate the next level values. If you observe here, BCD implies A and ACD implies B. When I am combining these two, the common values what I can have on the antecedent value is CD, and on the right hand side, that is nothing but the consequent value is AB. Therefore, I can generate the rule specifying that CD implies AB. Similarly, by combining all the rules in level 1, I can generate the rules like CD